Welcome back to our networking series part 2. Imagine the internet as a vast interconnected world of computers, websites, and services, but how do they find each other? When you type a web address like www.takqworld.com into your browser, something magical happens behind the scenes. The domain name system or DNS translates these human friendly names into the IP addresses that computers use to communicate. But there's another key player in this digital game, the host name. Host name help identify devices on a network in a way that makes sense to us. Whether it's a web server, app server, or DB server, host name keep everything organized. In this video, we will see host name and their roles in identifying devices on a network, a brief introduction to the domain name system and its importance in translating domain names to IP addresses, a comparison of public and private DNS highlighting their different use cases and functionalities, a detailed look at how public DNS servers resolve domain names and provide access to websites on the internet, a rundown of common DNS record types and their roles, and exploration of private DNS within the organization, showing how it manages internal network resources, step by step demonstrations of how to configure hostname and DNS settings on both Windows and Linux servers. A hostname is like a contact name in your phone, just as you save someone's phone number with the name to make it easier to remember and dial. A host name is essentially the label or name given to a device on a network, allowing you to connect to devices more easily without needing to remember complex IP addresses. In networking, devices communicate using IP addresses, which are numerical labels assigned to each device. Host names are used for human convenience, making it easier to identify and remember machines. To bridge the gap between host names and IP addresses, a DNS resolver is used. A DNS bridges the gap between host names and IP addresses by storing records of each device's host name and corresponding IP addresses. When a client device, such as a desktop, make a request to access a database using a host name, the request is sent to the DNS server. The DNS server translates the host name to an IP address and returns the resolved IP address to the desktop device. The desktop then connects to the database system and initiates communication. DNS can also reverse resolve IP address to host name if needed. DNS or domain name system is like a phone book that stores records of devices and their corresponding IP addresses. Private DNS is used within an organization to resolve internal host names to IP addresses, ensuring secure and efficient access to internal resources. Public DNS is used to resolve external domain names on the internet, allowing devices to access websites and services outside the organization. Now that we understand how host names are resolved in DNS and the basic differences between private and public DNS, let's look at an example starting with public DNS and see how it resolves a URL to an IP address through DNS. We will explore how a DNS query is processed and how the IP address is returned as a result. Enter the URL takqworld.com. The client sends a DNS query to its configured DNS server, usually provided by the ISP or public DNS server like Google's has 8.8.8.8. The DNS check its cache to see if it already knows the IP address for the URL. If the IP address is not in the cache, the DNS initiates a query process to find it. The DNS sends the query to the root server. There are 13 root name servers are available worldwide. The root servers don't know the exact IP address for the URL, but they know which servers responsible for the top level domain .com associated with the URL techworld.com. A top level domain is the last part of a domain name appearing after the final dot, and it categorizes domain by type or country such as .com, .edu, .net, .uk, .org, etc. In our case, it is .com. The root server doesn't provide an IP address for URL takqworld.com. Instead, it provides the IP address of the .com to the DNS. The DNS then queries the .com TLD server and check for takqworld.com IP address. It will check for this URL who is the authoritative name server for this domain. Example of authoritative name server include those managed by GoDaddy and Ionos. These companies host DNS record for domains purchased from them, making the domain available online and ensuring it cannot be registered by anyone else while active. In my case, I purchased the domain from Ionos, and the .com TLD name server respond by returning the IP address of the authoritative name server for techworld.com. The DNS resolver sends the query to one of the authoritative name servers for techworld.com. The authoritative name server checks its record and responds with the IP address associated with techworld.com. The DNS will cache this information, so next time it will not perform this task again. The DNS finally returns the IP address to client. Client start communication on the IP address to the server. Let's check the record type entries inside the DNS of the IONO server, starting with the A record. An A record or address record is a type of DNS record that maps a domain name to its corresponding IPv4 address. This is how the internet knows where to direct traffic when a user types in a domain name. A record acts like a phone book, translating a human readable domain name techworld.com into a numeric IP address like 76.223.105.230. When you access a link or type a domain name into a browser, the domain name typically resolves to an A record. This A record maps the domain name to the corresponding IP address, allowing your browser to connect to the correct server hosting the website. Next is a CNAME record. It allows you to direct user to different services using subdomains while keeping the main domain consistent. For example, blog.techworld.com points to a third-party blog provider at blogexample.com. I would set up a CNAME record that points blog.techworld.com to blogexample.com. Blog example will resolve to the A record with the IP address 1.2.3.4. The client will receive this IP and begin browsing this site. Using a CNAME like shop.techworld.com pointing to myshop.shopify.com, maintain branding while maintaining IP address with the third-party services or cloud providers. The NS record points to another name server that holds the A record for the client's query. When a request for the my.techworld.com is made, it is sent to the designated name server, which verifies the CNAME or A record for my.techworld.com. Once the A record is retrieved, it is sent back to the client. As we saw earlier, consider this a virtualized environment where we have different types of workloads such as DB, web, app, and HR running as VMs. We use a private DNS server within our organization to resolve the queries made by the VMs internally. We saw this example earlier where we resolve the DB hostname to an IP address. Now we look at example on Windows and Linux server for setting hostname and resolving DNS query using a DNS server. Last time we learned how to set the IP address in a Windows environment. Now we are going to first set the hostname and then add the IP of the DNS. In a Windows environment, enterprise organization typically have their own DNS setup within an Active Directory environment. We will join our VM to the AD domain and observe how the DNS records are automatically updated in the DNS server. Let's get started. To add the host name, right click on this PC and select Properties. Click on Change Settings. Then click on Change button. In the computer name field, enter the desired host name machine 1. Click OK, and the system will prompt for a reboot. Reboot the VM. After the reboot, enter your credentials and verify that the hostname has been changed to machine 1. We have already learned how to set the IP address. Now I will add IP for the DNS server, and we didn't add it previously. Next, we will join our VM to the domain. Right click on this PC and select Properties. Click on Change Settings. Click on the Change button. Under the member of domain option, I will enter my domain name, my example.local. It will then prompt for domain credentials. Once the credentials are entered, the VM will reboot and join the domain. Once the reboot completed, we will see two records: an A record named machine1 with IP address 192.168.10.10 in the forward lookup zone, and a pointer record in the reverse lookup zone. The A record maps the host name to the IP address, while the PTR record maps the IP address back to the host name. In the Active Directory DNS, the SOA record defines the primary authoritative DNS server for a zone and includes key administrative information for managing the zone's replication and updates. In AD DNS, the NS records specify the authoritative DNS server for a domain directing clients to the appropriate servers for name resolution within the Active Directory environment. Now we will test resolving the IP address to the host name and the host name to the IP address. Yes, we see that the IP is resolving. Last time we see how to set the IP address in a Linux environment. Now we will first set the DNS entries for the host name, my Linux, and IP address 192.168.10.15 in Active Directory for the Linux VM. After that, we will configure the DNS and host name on the Linux system. Let's get started. For the Linux platform, we will manually add a DNS server record, right click and select the new host A option. Enter the name of my Linux and the IP address 192.168.10.15. Then check the create associate pointer record option. We'll then verify that both the A and pointer records are updated in the DNS server. Now we are going to set the DNS IP, the search domain, and the host name for the VM. I've already prepared the commands which we will copy and paste into the terminal. First, set the DNS IP. Next, set the search domain. Finally, set the host name, and after once the host name is set, we will verify the host name by entering the command hostname. It will show us the new name of the host name, which is mylinux.myexample.local. After completing the setup, we will bring the network interface down and back up, then verify that the DNS is resolving both hostname to IP and IP to the hostname. And yes, we are seeing from IP to hostname. Now we are seeing it. Yes, it's resolved. No, the command copied wrongly. Paste, copy, and paste. Yes, it's resolving from IP to the hostname. The default port for DNS is port 53, which uses UDP to connect and query the DNS server from the client. And that's it. You now have a solid understanding of host names and the domain name system. In the next video series, we will dive into NTP ports, firewall communication, switch and router configurations, VLANs, and troubleshooting for setting up networking infrastructure. If you found this video helpful, don't forget to like, subscribe, share, and leave a comment. with any questions. Thank you for watching and happy networking.